Good evening, AP Physics students. Here we go. We have another sample problem here. We are going to do tonight from chapter number 5, problem number 30. All right. And this problem is about the moon. All right. It's kind of cool. Scientists like the moon. It's not Mars, but it's still pretty cool. So this problem states the moon has a mass of, and they give us the mass of the moon, 7.35 times 10 to the 22nd kilograms. And it also says that the radius of the moon, right, r sub m, I'm going to call that, and they give us a number for that, 1.74 times 10 to the 6th meters. And then the problem basically states, with that information, figure out the acceleration due to gravity on the moon. All right. And you're thinking, man, that doesn't seem like there's enough information to figure out the acceleration due to gravity on the moon. But let's see what we can do. Okay, so let's say I'm on the moon and I'm in free fall. So I'm just above the surface of the moon and someone drops me, right? What forces are acting on me? Well, I got a force of gravity. And the gravity from the moon is pulling me down, all right? Okay, so if I'm going to figure out the acceleration that gravity is causing, though, I'm going to start with Newton's second law, right, which states that the acceleration of an object is equal to the net force divided by the mass of the object, right? So here m is the mass of, I don't know, me or you or the object, right? All right, well, how big is this force that the moon is pulling down on me with? Well, I know I could use Newton's universal law of gravitation to figure out what that force is, right? Newton's universal law of gravitation says that force is equal to big G, gravitational constant, times the mass of the moon, times the mass of me, divided by the radius of the moon squared, right? Why the radius? Because that's the distance between the center of mass of the moon and the center of mass of you or me or whoever's on the moon, all right? And what's nice about this is a fraction, right? Well, what if I multiply this fraction by top and bottom by 1 over m? Oh, the mass of u cancels out, right? So the acceleration due to gravity on the moon should be equal to big G times the mass of the moon divided by the radius of the moon squared, right? Kind of crazy that it's that simple. But let's go back here for a second. This is why the acceleration due to gravity is the same for all objects on the surface of a planet, regardless of the mass of the object, right? So that mass cancels out. Okay, let's plug in some numbers here. Big G, Newton's universal gravitation, 6.67 times 10 to the minus 11th. You can find this number on your table of information. Don't have to memorize that. Mass of the moon, 7.35 times 10 to the 22nd. And radius of the moon here. By the way, big G, this number here, all right, the units on this is newtons times meters squared per kilogram squared. So whenever you use this formula for Newton's universal law of gravitation, make sure everything's in kilograms and meters. Okay. Okay. Radius of the moon from up here, 1.74 times 10 to the 6th, and we got to square that. Now, be careful when you type this all in your calculator. There's lots of exponents and parentheses. But believe it or not, you punch all of that in, and you get A is 1.62 meters per second squared. And that is the acceleration due to gravity on the moon. And this would work for any planet. As long as you know its radius and its mass, you can figure out the acceleration due to gravity there, which is kind of neat. Nice work, physics students. Special treat today as your reward for being so attentive. This is going back a little ways. This is a picture. Ooh, where's the glare? There. This is a picture of the homecoming court for Jefferson High School in 1993. Very formal picture taken here back in the days when it was really formal. And if we zoom in super close over here, we might find a very handsome senior ambassador with some long flowing gorgeous hair, right? What a good looking senior ambassador. Not quite as good looking as Johnny Chow, who kicked my tail in being an awesome senior ambassador, but I was a close second. So anyway, nice work, AP physicists. Keep up the good work.